Perhaps beyond human translation, harnessing multi-agent collaboration for translating ultra-long literary texts. Authors Minghao Wu, Yulin Yuan, Golem Reza Hafari, Longyue Wang. Abstract. Recent advancements in machine translation have significantly enhanced translation quality across various domains. However, the translation of literary texts remains a formidable challenge due to their complex language, figurative expressions, and cultural nuances. In this work, we introduce a novel multi-agent framework based on large language models for literary translation, implemented as a company called TransAgents, which mirrors traditional translation publication process by leveraging the collective capabilities of multiple agents to address the intricate demands of translating literary works. To evaluate the effectiveness of our system, we propose two innovative evaluation strategies: monolingual human preference and bilingual LLM preference. MHP assesses translations from the perspective of monolingual readers of the target language, while BLP uses advanced LLMs to compare translations directly with the original texts. Empirical findings indicate that despite lower 4 blue scores, translations from TransAgents are preferred by both human evaluators and LLMs over human written references, particularly in genres requiring domain-specific knowledge. We also highlight the strengths and limitations of TransAgents through case studies and suggest directions for future research. Figure 1, an illustration of our method. Traditional machine translation systems often underperform compared to human translators. In this study, we demonstrate that the translations produced by our TransAgents are more preferred by humans than those from conventional MT systems. 1. Introduction. Machine translation has achieved remarkable advancements in recent years, driven by breakthroughs in deep learning and neural networks. Despite these technological strides, literary translation remains an unresolved challenge for MT systems. Literary texts, characterized by their complex language, figurative expressions, cultural nuances, and unique stylistic elements, pose significant hurdles that are hard for machines to overcome. This complexity makes literary translation one of the most challenging areas within machine translation, often referred to as the last frontier of machine translation. In response to complex challenges across various domains, recent research in multi-agent systems, particularly those powered by large language models, has shown significant promise. These systems leverage the collective intelligence of multiple agents, enabling superior problem-solving capabilities compared to individual model approaches. Multi-agent systems excel in dynamic environments where intricate problem-solving and collaborative efforts are required. Given the nature of literary translation, we harness the superior capabilities of multi-agent systems and establish a novel multi-agent translation company for literary translation, called TransAgents. At TransAgents, the translation process is organized into two main stages, each consisting of several sub-stages. The process begins with the selection of a senior editor by our predefined CEO agent, who chooses based on the specific requirements of each client. The selected senior editor then assembles a team from our roster, which includes roles such as junior editor, translator, localization specialist, and proofreader. Each team member collaborates through multiple substages, employing strategies like addition by subtraction collaboration and trilateral collaboration to refine and enhance the translation output. Furthermore, evaluating the accuracy and quality of literary translations presents a particularly challenging task due to the subjective nature of literature and the potential interpretations in reference translations. To effectively address these challenges, we propose two innovative evaluation strategies: monolingual human preference and bilingual LLM preference. Both strategies involve comparing a pair of translations from two different translation systems to determine which one is superior. The monolingual human preference strategy simulates the realistic scenario of reading a translated work. It engages human evaluators from the target audience who assess translations without the influence of the original text. This approach focuses on how well the translation resonates with the readers in terms of fluidity, readability, and cultural appropriateness, mirroring the real-world consumption of literature. Conversely, the bilingual M preference leverages the capabilities of advanced LLMs, specifically GPT-4 125 Preview. In this strategy, The LLMs are provided with the original texts to facilitate a direct comparison. This method aims to harness the superior translation capabilities of advanced LLMs, mitigating the impact of imperfect reference translations. Our empirical findings reveal that TransAgents consistently delivers the poorest performance in terms of D-Blue scores. However, it is preferred over both human-written references and GPT-4 translations by human evaluators and an LLM evaluator. In-depth analysis shows that TransAgents excels over human-written references in genres that demand domain-specific knowledge, such as historical contexts and cultural nuances, but it falls short in contemporary genres. Additionally, we observe that TransAgents is capable of generating translations with more diverse and vivid descriptions. Our cost analysis indicates that using TransAgents for literary text translation can result in an 80 times reduction in costs compared to employing professional human translators. Nonetheless, we also identify significant limitations in LLM-based translation systems, including both GPT-4 and TransAgents, particularly with issues related to significant content omission. In this work, our contributions can be summarized as follows. We introduced TransAgents, a novel multi-agent system for literary translation, which mirrors the traditional translation publication process. By employing a multi-agent approach, this approach addresses the complex nuances of literary works. We propose two novel evaluation strategies: monolingual human preference, MHP, and bilingual LLM preference, BLP, to assess the quality of translations. MHP focuses on the translation's impact on target audience readers, emphasizing fluidity and cultural appropriateness, while BLP uses advanced LLMs to compare translations directly with the original texts. Despite lower DBU scores, our empirical findings highlight that translations from TransAgents are preferred by both human evaluators and language models over human-written references. We also present in-depth analyses about the strengths and weaknesses of TransAgents. 2. Related work. Large language models, LLMs, have revolutionized the field of artificial intelligence, AI. These models are typically pre-trained on a vast corpus of text data, learning to predict the next word in a sentence. After pre-training, the models are fine-tuned with instructions. This process, known as supervised fine-tuning, SFT, or instruction tuning, IT, allows the model to adapt its general language understanding to follow and implement instructions from humans. Thanks to the superior capabilities of large language models, recent works demonstrate that synthetic datasets generated by these models can also be used in this step. Furthermore, reinforcement learning from human feedback, RLHF, is used to further improve the performance of these models. In this approach, the model is fine-tuned based on feedback from humans or other large language models who rate the quality of the model's outputs. Moreover, evaluating these large language models is a complex task, often involving both automated metrics and human judgment. Additionally, these models pose challenges in terms of efficient training, hallucination, and other issues which are also active areas of research. In this work, we leverage the state-of-the-art LLM as the backbone of our multi-agent system for translating the literary texts. Multi-agent systems' intelligent agents are designed to understand their environments, make informed decisions, and respond with appropriate actions. The capabilities of large language models, LLMs, align well with these expectations. The emergence of LLMs has significantly advanced research on multi-agent systems across various contexts. Multi-agent systems, compared to single-agent setups, are generally expected to either leverage collaboration among multiple agents to tackle complex problems or use diverse agents to effectively simulate complex real-world environments. Recent studies have shown promising outcomes in complex problem-solving areas such as software development, multi-robot collaboration, evaluation, and fact-checking. Additionally, there is extensive research on using multiple agents to simulate real-world environments, including societal, economic, and gaming simulations. Liang proposes leveraging multi-agent debate for machine translation. However, their approach is limited to the sentence level. In this work, we focus on the first category, specifically on the translation of literary texts. Literary translation is considered one of the most complex and challenging translation tasks, and we aim to address this challenge using a multi-agent system powered by LLMs. Machine translation. Machine translation, MT, has achieved significant advancements in recent years, with developments spanning general-purpose MT, low-resource MT, multilingual MT, and non-autoregressive MT, among others. However, these advancements are predominantly focused at the sentence level. Recently, efforts are made to enhance translation quality by integrating contextual information into the translation process, aiming to achieve more accurate and coherent translations that extend beyond individual sentences. More recently, large language models have demonstrated superior capabilities in various applications, including MT. Given the remarkable progress in machine translation, MT, the performance of MT seems to be saturating in the general domain. There is growing interest in literary translation, which is considered one of the more challenging translation tasks because it requires not only accuracy in meaning, but also the conveyance of vivid expressions and cultural nuances. Additionally, evaluating MT accurately remains a critical aspect of research in this field. While traditional metrics like BLEU are commonly used, newer approaches involve utilizing pre-trained language models to assess translation quality more effectively. Cockme and Fetterman 2023 employ the state-of-the-art LLM, GPT-4, to estimate translation quality and achieve state-of-the-art quality estimation performance at WMT 2023, Freitag et al. 2023. In this work, we establish a novel multi-agent virtual company, TransAgents, for translating literary texts. We also propose 2 evaluation strategies for assessing the quality of the translated literary texts. 3. TransAgents, a multi-agent virtual company for literary translation. Figure 2. TransAgents, a multi-agent virtual company for literary translation. We establish a virtual multi-agent translation company, TransAgents, featuring a diverse range of employees, including a CEO, senior editors, junior editors, translators, localization specialists, and proofreaders. When a human client assigns a book translation task, a team of selected agents from TransAgents collaborates to translate the book. This paradigm simulates the entire book translation process, where agents with different roles work together to ensure that the translation maintains high quality and consistency throughout. In this section, we describe the company overview of TransAgents in Section 3.1, the core collaboration strategies of TransAgents in Section 3.2, and the translation workflow in Section 3.3. 3.1. Company Overview. To simulate the entire book translation process, in addition to the designated CEO, we have a diverse array of roles, including senior editors, junior editors, translators, localization specialists, and proofreaders in our company TransAgents. Each of these roles carries its own set of responsibilities. Senior editors. Senior editors are responsible for overseeing the content production process. Their primary duties encompass setting editorial standards, guiding junior editors, and ensuring that the content aligns with the company's objectives. Junior editors. Junior editors work closely under the guidance of senior editors. Their responsibilities typically include managing the day-to-day editorial workflow, editing content, and assisting in content planning. They also handle communications with various other roles within the organization. Translators. Translators are tasked with converting written material from one language to another while preserving the tone, style, and context of the original text. Translators must possess a profound understanding of both the source and target languages, as well as a familiarity with the subject matter they are translating. Localization specialists. Localization specialists go beyond simple translation. They adapt content for specific regions or markets. This role involves not only translating language, but also adjusting cultural references, idioms, and images to resonate with local audiences. Proofreaders. Proofreaders perform final checks for grammar, spelling, punctuation, and formatting errors. Their role is crucial in ensuring that content is polished and adheres to high-quality standards before publication. To enhance the realism and efficacy of our simulation in the translation process, we strategically utilize GPT-4 Turbo to generate a diverse set of 30 virtual agent profiles for each distinct role. As illustrated in Figure 3, these profiles are comprehensively designed to include a wide array of attributes that extend well beyond language skills. Key characteristics such as gender, nationality, rate per word, educational background, years of experience, and areas of specialization are thoughtfully incorporated. This detailed and personalized approach not only enriches the authenticity of the translation process simulation, but also mirrors the complexity and diversity found in real-world translation settings. The inclusion of such rich, detailed metadata about the agents not only enhances current simulation strategies, but is also designed to support and inspire future research. Figure 3. An example profile of senior editor. 3.2. Agent collaboration strategies. In this section, we introduce 2 collaboration strategies used in this work, including addition by subtraction collaboration, algorithm 1, and trilateral collaboration, algorithm 2. Addition by subtraction collaboration. In our framework, we propose the addition by subtraction collaboration between 2 agents. Unlike the debate-style strategy and third-party agent concludes the discussion, our strategy involves only 2 agents. One acts as an addition agent, responsible for extracting as much relevant information as possible, while the other agent serves as a subtraction agent, tasked with reviewing the extracted information, eliminating redundant details, and providing feedback to the addition agent. We present the details of our collaboration strategy in algorithm 1. The addition agent at first generates the initial response, aiming to include as much informative content as possible. Subsequently, the subtraction agent reviews the response and removes any redundant information. The conversation iterates until no further revisions are needed for the response. Algorithm 1, addition by subtraction collaboration input, context C, instruction I, maximum number of iterations M, addition agent A, subtraction agent S, output, the final response R that both agents agree upon. H initialize the conversation history, R initialize the response, M0 current round, while M is less than or equal to M do MM plus 1, R prime A of H, generate detailed response, FS of H, R prime, review and remove redundant information. HH concatenated with R prime and F, append R prime and F to the conversation history H. If R prime equals R, then L break. Stop iterating as no further revisions are needed, R prime, return the final response R. Algorithm 2, trilateral collaboration input, context C, instruction I, maximum number of iterations M, action agent P, critique agent Q, judgment agent J. Output, the final response R that is approved by the judgment agent J. H initialize the conversation history, M0 current round, while M is less than or equal to M do MM plus 1, R prime P of H. Generate response, FQ of H, R prime generate critiques, HH concatenated with R prime, and F append R prime and F to the conversation history H. If M is greater than 1, then DJ of C, I R prime. The judgment agent J evaluate the response quality. If D equals true, then L break stop iterating if the judgment agent J thinks the response is of high quality. Return the final response R. Trilateral collaboration. We divide the collaboration into 3 branches in transagents, referring to as trilateral collaboration. Action. The power to follow the instruction and implement the required actions. Critique, the power to review the generated response and provide constructive feedback to the action branch. Judgment, the power to make the final decision on whether the response is satisfactory or requires further revision. We assign 1 agent for each branch and present the details of the collaboration among these agents in algorithm 2. The action agent P generates a response R given the context C and instruction I. The critique agent Q then writes critiques F against the response R. The action agent P has the option to either accept the critiques and update the response or maintain the original response. At the end of the iteration, the judgment agent J evaluates the response R to determine if the discussion can be concluded or if further deliberation is required. 3.3. Translation workflow. In this section, we introduce the book translation workflow in our company transagents, including 2 main stages, preparation, section 3.3.1, and execution, section 3.3.2. 3.3.1. Preparation. Project members selection. System prompts or messages are used to assign roles to individual agents during the role-playing process. In our company's setup, we create 30 agent profiles, each accompanied by a unique role assignment prompt, as illustrated in Figure 3. These prompts are essential for assigning specific roles to the agents before the dialogues begin. Within our framework, the initial step involves the CEO selecting a senior editor for the book translation project. This selection process takes into account both the client's requirements and the qualifications of potential senior editors. Once the senior editor is chosen, they work closely with the CEO to assemble the rest of the project team, carefully considering the skill sets and backgrounds of the candidates. Furthermore, we introduce a self-reflection strategy. This strategy involves incorporating a ghost agent whose task is to prompt the CEO to reconsider their decision, as we observe that they sometimes struggle to select a senior editor with the desired language skills. Translation guideline documentation. To maintain consistency throughout the entire translation workflow, which involves multiple agents, we need to have a translation guideline. In TransAgents, there are 5 components: the glossary, the book summary, the tone, the style, and the target audience. We have designed different strategies to process them. Glossary. The primary purpose of a glossary in book translation is to compile essential terms from the source language and provide their corresponding translations in the target language. This ensures consistency and accuracy in the usage of these terms throughout the book, especially since some terms may have multiple acceptable translations. In our process, we leverage the addition by subtraction collaboration, as described in Algorithm 1, for collecting the key terms. For each chapter, the junior editor, serving as the addition agent A, makes an exhaustive attempt to identify all potential key terms initially. Subsequently, the senior editor, serving as the subtraction agent B, reviews the list of identified terms and removes any that are generic. The conversation continues until the list of collected key terms does not need further revision. Next, the collected key terms are translated by the senior editor with consideration of their context. Book summary. Generating a book summary is crucial to provide a comprehensive overview of the narrative. This task is facilitated by the collaboration between the junior editor, addition agent A, and the senior editor, subtraction agent B, employing the addition by subtraction collaboration, as depicted in Algorithm 1. In this process, the junior editor aims to retain as much detail as possible in the chapter summaries, while the senior editor focuses on removing superfluous information. Following the compilation of chapter summaries, the senior editor then crafts the book summary, mirroring the process of gathering a glossary. Tone, style, and target audience. The translation of a book is more than just a word-for-word conversion. It's a delicate process of adapting tone, style, and content to resonate with the target audience while staying true to the original text's essence. In TransAgents, the senior editor defines the tone, the style, and the target audience of the translated book based on a randomly selected chapter. Overall, the glossary, book summary, tone, style, and target audience collectively constitute the comprehensive translation guidelines. These guidelines serve as an essential part of the prompts for all roles involved in the book translation process, ensuring consistency and coherence throughout the entire work. 3.3.2 Execution. In the execution phase, the process is divided into 4 distinct substages: translation, cultural adaptation, proofreading, and final review. During the first 3 substages, our approach utilizes the collaborative strategy as illustrated in Algorithm 2. Within this framework, the roles of Action Agents P are assigned to the translator, the localization specialist, and the proofreader, in that order. Meanwhile, the responsibilities of the Critique Agent Q and the Judgment Agent J are fulfilled by the junior editor and the senior editor, respectively. Finally, the senior editor performs the final checks before publication: translation, localization, and proofreading. The translation stage involves 3 key roles: the translator, the junior editor, and the senior editor. These roles collaborate to translate the book from the source language to the target language on a chapter-by-chapter basis. The translation process begins with the translator, the action agent P, initially translating the chapter content from the source language to the target language. Next, the junior editor, the critique agent Q, undertakes a thorough review of the translation, ensuring it adheres to the guidelines while also identifying any potential errors or areas for improvement. Lastly, the senior editor, the judgment agent J, evaluates the translation and determines if further revision is needed. Following the translation, the cultural adaptation process begins. the localization specialist tailors the translated content to fit the cultural context of the target audience, ensuring that it resonates well and maintains the intended meaning. Next, the proofreader performs the checks for language errors. Throughout the cultural adaptation and proofreading stages, both the junior editor and the senior editor continue to offer critiques and evaluations to refine the content further. Final review. The final review is the concluding step in the editorial process. At this point, the senior editor evaluates the translation quality of each chapter and also examines how pairs of adjacent chapters flow into each other. The senior editor not only verifies that each chapter is internally coherent and meets quality standards on its own, but also ensures that the transitions between chapters are smooth, thereby maintaining narrative consistency. On the importance of the judgment agent, we introduce the judgment agent in Algorithm 2, which is responsible for evaluating the quality of the response and determining whether further revision is needed, without requiring the conversation history. Owing to the nature of web novels, each turn of dialogue is likely to contain a few thousand words. Although recent advances in large language models, LLMs, claim that LLMs are capable of processing extremely lengthy sequences of up to millions of tokens, we still observe that our agents are not able to effectively leverage the information in the context as the conversation expands. Additionally, we observe that the meaning of translations tends to deviate from the original text after several iterations of revision. Therefore, it is critical to have the judgment agent within the trilateral collaboration to ensure the overall quality of the response. 4. Experimental setup. In this work, our experimental setup primarily follows the WMT 2023 shared task on discourse-level literary translation DLLT Wang et al. 2023b. The following sections introduce the baselines, Section 4.1, datasets, Section 4.2, and evaluation approaches, Section 4.3 used in our study. 4.1. Baselines. We leverage the state-of-the-art LLM, GPT-4 Turbo, as the backbone of our agents, and compare our approach with the unconstrained systems in WMT 2023 shared task on DLLT. 1. Llama MT, Du et al. 2023b, fine-tuned Llama 7b for literary translation. The fine-tuned Llama MT model translates 2,048 consecutive tokens at a time. 2. GPT-4. While recent versions of GPT-4 models claim to support a context size of up to 128,000 tokens, they are restricted to generating a maximum of 4,096 tokens per response, OpenAI 2023. Therefore, we employ the GPT-40613 and GPT-41106 preview models to translate the documents on a chapter-by-chapter basis. 3. Google. We employ the Google Translate system to translate the documents on a sentence-by-sentence basis. 4. Zhao et al. 2023 explore several techniques to enhance the performance of large language models, LLMs, in discourse-level translation tasks. 5. HWTSC, Xie et al. 2023 initially train a sentence-level transformer to establish a baseline, subsequently enhancing its discourse-level capabilities through domain adaptation and discourse modeling, employing a variety of techniques. 4.2. Datasets. In this work, we do not need to train new models, and all the agents is GPT-4 Turbo with various roles. Hence, we only leverage the official test set of WMT 2023 shared task on DLLT. The official test set is collected from 20 web novels, each of which consists 20 consecutive chapters, totaling 240 chapters. The test set contains 2 references. Reference 1 is translated by human translators, and Reference 2 is built by manually aligning bilingual text in web page. 4.3. Evaluation. Translating literary works differs significantly from translating standard machine translation corpora, such as news articles or parliamentary proceedings. Tai et al. 2022 present a comprehensive list of techniques employed by literary translators, which largely differ from those used in common MT domains. Furthermore, literary translators have the freedom and the burden of both semantic and critical interpretation, resulting in the absence of a single unique best translation for literary texts. In this work, we employ 2 evaluation approaches. Standard evaluation, following Wang et al. 2023b, we use DBlue, Papanini et al. 2002, Post 2018, Liu et al. 2020, to evaluate the translation quality, as the translations may not strictly align with the source text on a sentence-by-sentence basis. To compute the D-Blue score, we concatenate all the chapter translations into a single document for evaluation. We present the results in Section 5. Preference evaluation. Acknowledging the concern that there is no single, universally preferred translation for literary texts, we ask human raters, or LLMs, to select their preferred translation without giving them a reference translation. Further details regarding this evaluation approach are discussed in Section 6. 5. Standard evaluation. We present the automatic evaluation results in Table 1. Interestingly, our approach performs poorly in terms of the D-Blue metric, achieving the lowest scores among the compared methods. However, it is important to consider that D-Blue has limitations and may not fully capture the quality and coherence of the generated text. As pointed out by Freitag et al. 2020, typical references used for calculating D-Blue scores often exhibit poor diversity and tend to concentrate around transliteration's language. This suggests that a low D-Blue score does not necessarily imply poor performance of our approach. Our results align with the findings from Tai et al. 2022, who argue that automatic metrics cannot accurately reflect human preference in the context of literary translation. Furthermore, while automatic metrics are typically highly correlated with human judgments based on the multidimensional quality metrics MQM framework, Blanchard, 2013, this framework may not be suitable for assessing translation quality in the context of literary translation. The unique characteristics and creative aspects of literary texts require a more nuanced evaluation approach that goes beyond the scope of standard automatic metrics in MQM-based human assessments. Table 1. Automatic evaluation D-Blue results on WMT 2023 DLLT test set. Higher is better. The worst result is highlighted in bold. Question: which of the following writing style do you prefer? 1. Chapter 455. Turnaround 3. Allow me to demonstrate the sensing of formless fluctuation. It's remarkably straightforward, interjected another sorcerer, a smile evident in his voice. Your assistance is appreciated, Lin Sheng responded, offering a nod of gratitude. Zhao was of the essence in finding the remaining fragments. He had initially planned to conquer an array of great evil spirits to amass substantial reserves of pure soul power. Yet the present opportunity necessitated an immediate and decisive acquisition. Promptly, the sorcerer leader brought Lin Sheng to a daunting evil spirit gate. Both extended their hands, gently touching the gate's sempiternal frame, eyes closed as one. The leader rapidly employed his special ability to establish a spatial foundation, thus setting a coordinate code. 2. Chapter 455, Perversion 3. This is to let you feel the fluctuation of aura. It's really simple. Another warlock couldn't help but interrupt with a smile. Then I'll have to trouble you, Lin Sheng nodded. He needed to find the other fragments as soon as possible. Originally, he had planned to conquer more evil spirits and obtain more pure soul power. But now that he encountered such an opportunity, the most important thing for him was to get it as soon as possible. Soon, the warlock commander led Lin Sheng to an evil spirit gate. The two reached out, touched the frame of the evil spirit gate at the same time, and closed their eyes. The warlock commander quickly used his ability to build the space base as a coordinate. 3. No preference. Figure 4. The user interface for monolingual human preference, MHP. X indicates the selection of human evaluator. 6. Preference evaluation. It is crucial to acknowledge that a literary text does not possess a single, universal translation. Conventional translation evaluation methodologies, which typically rely on direct comparisons to a standard reference translation, fail to accommodate the multifaceted and subjective nature of literary texts. Following Lai et al. 2022, we explore both human evaluators and large language models, LLMs, to assess translations based on their human preference. In this section, we describe our methods and present initial findings in Section 6.1 and our results in Section 6.2. 6.1. Evaluation methods. In this section, we propose two preference evaluation methods, monolingual human preference, MHP, Section 6.1.1, and bilingual LLM preference, BLP, Section 6.1.2. For both methods, we use the winning rate percent, which is the percentage of instances where a model's generated chapter is preferred by either the human evaluators in MHP or the LLM in BLP to measure the model performance. 6.1.1 Monolingual human preference. When reading a translated book, it is not necessary for the reader to understand the original language. Therefore, a better translation should naturally be preferred by readers without needing to refer to the text in its original language. Pre-processing. In this work, the translations of each chapter are first manually split into several segments containing approximately 150 words each, based on the story's plot. This translation segmentation step is necessary because the full translations contain thousands of words, and human evaluators may struggle to stay focused when evaluating such long passages at once. Evaluation. The human evaluators are tasked with comparing pairs of translation segments, describing the same part of the story, and selecting their preferred translation for each segment pair, with the user interface shown in Figure 4. To ensure evaluations consider the full context, each evaluator is required to evaluate all the segments within a chapter in their original order, as segments may depend on information from previous segments. Implementation. In this study, we collect human preferences on translations through SurveyMonkey. To ensure the evaluators are from the target audience, we ask if they are interested in Chinese web novels before starting the evaluation. We only recruit evaluators from the United States to minimize potential impacts of demographics. Each translation pair is evaluated by at least 10 people and costs us 30 cents USD per annotation. We filter out possible low-quality responses or human evaluators based on following criteria: being labeled as low quality by SurveyMonkey's response quality model, giving no preference for all selections, taking less than 20 seconds for the evaluation. After filtering, we collect at least 5 responses per segment pair. Mitigating positional bias. Human evaluators may exhibit a positional bias when evaluating response quality. To mitigate this bias in our translation evaluations, the positions of the translation segments being compared are randomly swapped for each selection, as shown in Figure 4. Furthermore, the no preference tie option, indicating that the evaluator does not prefer one translation over the other, is always presented as the third option. Response aggregation. We aggregate the human evaluations using majority voting, where the most selected option is considered the final preference. If 2 translation systems receive the same number of votes, we record the final preference as no preference, tie. 6.1.2 Bilingual LLM preference. The nature of literary texts with their inherent complexities, artistic expression, and cultural nuances makes it virtually impossible to produce a single, universally correct translation. As a result, multiple translations of the same literary text can coexist, each offering a unique perspective and interpretation. Recent works demonstrate that the reference translations are likely to be of low quality. Kokmi and Fetterman in 2023 demonstrate that GPT-4 is capable of accurately estimating translation quality without the need for human reference translations. Their proposed GEMBA MQM metric achieves state-of-the-art performance in WMT 2023 metric shared task. Motivated by Kokmi and Fetterman in 2023, we evaluate the translation segment pairs using GPT-4 0125 preview without providing the reference translations. Recent research demonstrates that even state-of-the-art LLMs may struggle to process extremely long sequences. Therefore, we require GPT-4 0125 preview to determine which translation segment is better, as described in section 6.1.1, using the prompt shown in Figure 5. Instead of directly comparing the quality of 2 entire chapters, we employ a different variant of GPT-4 for evaluation to avoid the potential bias. Given concerns about positional bias in LLM evaluation raised by recent studies, we evaluate each translation segment pair in both forward and reverse directions. 6.2 Experiments. Setup. As described in section 4.2, there are 12 web novels consisting of 240 chapters in our test set. Due to the high cost of human evaluation, we only compare our transgents with the reference one and GPT-4 1106 preview models. We evaluate the first 2 chapters of each of the 12 web novels in our test set using both of our preference evaluation methods. Figure 5. the prompt used for bilingual LLM preference evaluation. Figure 6, monolingual human preference evaluation results. GPT-4 indicates GPT-4 1106 preview. Figure 7, bilingual LLM preference evaluation results. GPT-4 indicates GPT-4 1106 preview. Table 3, the breakdown winning rate of transagents against GPT-4 1106 preview and reference 1. The best results are highlighted in bold, the worst results are highlighted in underline. Results. We compare the performance of our transagents with reference 1 and GPT-4 1106 preview using monolingual human preference evaluations. The results, presented as winning rates, are shown in Figure 6. The translations produced by transagents are marginally preferred by human evaluators compared to both reference 1 and GPT-4 1106 preview. Additionally, we evaluate the models using bilingual LLM preference, with the results presented in Figure 7. The translations generated by transagents are also more preferred by GPT-4 0125 preview compared to the other models. Referring to the results in Table 4, we observe that GPT-4 0125 preview appears to have a strong preference for diverse and vivid descriptions when evaluating literary translations. We leave the further investigation to the future work. 7. Analysis. What causes transagents to fail in terms of D-Blue? As shown in Table 1, the translation produced by transagents achieves the lowest D-Blue score among the compared methods. To investigate the reasons behind this, we evaluate the output of each stage in the transagents workflow using the official references from the WMT 2023 DLLT test set. The results presented in Table 2 reveal that, although the backbone of the agents in transagents is GPT-4 1106 preview, the initial translation produced by transagents achieves a significantly lower D-Blue score. This suggests that the translation guideline is the main contributor to the final translation quality. Moreover, the localization step further reduces the D-Blue score, while the proofreading step only minimally modifies the translation. Strengths and weaknesses of transagents. The original texts of the test examples are publicly accessible online and span a variety of genres, including video games, Eastern fantasy, sci-fi romance, contemporary romance, fantasy, science fiction, horror and thriller HT, and fantasy romance FR. We present a detailed analysis of the performance of our model transgents across these categories in Table 3. Our observations indicate that transgents excels in domains that demand extensive domain-specific knowledge, such as historical contexts and cultural nuances. These areas often pose significant challenges for translators. On the other hand, transgents tends to underperform in contemporary domains, which may not require as much specialized knowledge. This performance trend underscores the model's strengths and weaknesses. Linguistic diversity. Linguistic diversity in literary texts is critical for enriching the reading experience. To quantify the linguistic diversity of the translation, we leverage two metrics: the moving average type token ratio, Matt R., Covington and McFall, 2010, and the measure of textual lexical diversity, MTLD, McCarthy and Jarvis, 2010. As shown in Table 4, assisted by our translation guidelines, our initial translation significantly improves linguistic diversity compared to the source text. Moreover, the localization step further enhances linguistic diversity, while the proofreading step does not affect it. These results demonstrate the effectiveness of our approach in preserving and enhancing the richness of language in the translated literary work. Cost analysis. The cost of human translation services can be influenced by several factors, including the genre of the text, the translator's location, and their level of experience. The American Translators Association recommends a minimum rate of 12 cents per word for professional translation services. The reference 1 from the WMT 2023 DLLT test set contains an average of 1,104 English words per chapter, resulting in a translation cost of $168.48 USD per chapter. In comparison, translating using transgents costs approximately $500 USD for the entire test set, which is equivalent to $2.08 USD per chapter. Translating literary text using transgents can lead to an 80 times reduction in translation costs. 8 case study. In this section, we explore 2 case studies with regard to cultural adaptation and content omission, shedding light on both the strengths and weaknesses of our approach. Additionally, we enrich our analysis by incorporating insights from interviews with 2 experienced professional translators. Cultural adaptation. In Chinese, job titles are typically placed before a person's name, whereas in English, job titles usually come after the person's name. This order reflects differing linguistic and cultural conventions regarding the structuring of personal information in the 2 languages. As demonstrated in Table 5, Transgence is the only system that accurately reflects this cultural context in its translations. In contrast, both Reference 1 and GPT-4 1106 Preview fail to correctly adjust the order of names and job titles, thus not adhering to the cultural norms expected in the target language. The ability to produce translations that are not only linguistically accurate, but also culturally appropriate is crucial. This emphasizes the capability of Transgence to provide translations that are culturally appropriate, ensuring an immersive reading experience for readers in the target language. Global consistency. It is important to maintain consistency throughout the book translation from the start to the end. As shown in Table 6, the chapter titles are consistent, with the exception of the index. Both Reference 1 and Transgence successfully produce consistent translations. Table 5. Case Study for Cultural Adaptation. The text highlighted in red indicates that the translation is accurate in meaning, but not in cultural context. The text highlighted in blue indicate that the translation is accurate both in meaning and in cultural context. Table 6. Case Study for Global Consistence. The text highlighted in red indicates that GPT-4.1106-Preview generates inconsistent translations across different chapters. However, GPT-4.1106-Preview struggles with maintaining consistency across different chapters. This demonstrates that TransAgents is capable of maintaining consistency throughout the entire translation process, similar to human translators. Content omissions from TransAgents is generally preferred over both Reference 1 and GPT-4.1106-Preview, according to evaluations by human judges and large language models, LLMs, Figure 6 and Figure 7. However, despite its higher preference, the translations produced by TransAgents are not without flaws. A detailed analysis of the translated chapters, when divided into smaller segments, reveals that both GPT-4.1106-Preview and TransAgents exhibit significant issues with content omission, as illustrated in Table 7. While these omissions do not seem to impact the overall development of the story plot, they could potentially influence other critical aspects of the narrative. For example, missing content could diminish the depth of character development or alter the intended emotional impact of the text. Such omissions, therefore, raise concerns about the completeness and fidelity of the translation in preserving the nuanced expressions and thematic elements of the original texts. Comments from professional translators? We anonymize the translations from TransAgents, Reference 1, and GPT 4.1106-Preview for a randomly selected chapter, and present both the original text and the translations to 2 experienced professional translators. We request that they assess and rank the quality of each translation and provide their comments on the translations. As shown in Table 8, both Translator A's and Translator B's comments highlight the novel-like, expressive translation style of TransAgents, which uses sophisticated language, though it sometimes omits parts of the original text. Reference 1 and GPT 4.1106-Preview stick closer to the original text. Overall, TransAgents' translations are viewed as the most expressive and engaging, Reference 1's as straightforward, and GPT 4.1106-Previews as the most traditional. These comments confirm that TransAgents is capable of producing more expressive and engaging translations compared to Reference 1 and GPT 4.1106-Preview. 9 limitations. The primary limitation of our study centers on the evaluation methods used. Extensive literature has highlighted the issues in conventional machine translation (MT) evaluation techniques, such as poor evaluation metrics and the reliability of reference translations. Papanani et al., 2002, Post 2018, Rai et al., 2020, Freitag et al., 2021, etc. Beyond traditional MT evaluation metrics such as B-Blue, we propose additional methods, namely monolingual human preference and bilingual LLM preference, to assess translation quality. Table 7. Case study for content omission. The text highlighted in red and blue indicates the content that is omitted by TransAgents. The text highlighted in red represents the content that is omitted by GPT 4.1106 preview. Table 8. Comments from 2 experienced professional translators on the translations from TransAgents Reference 1 and GPT 4.1106 preview. We present both the original text and the anonymized translations to 2 experienced professional translators. The original comments are written in Chinese, and we make adaptations while preserving their original meaning. We replace the anonymized system names with the actual system names to improve readability. The translation systems are highlighted in red. However, the implementation of these novel evaluation strategies introduces several challenges that may undermine the validity of our findings. Document segmentation. Evaluating ultra-long texts introduces distinct challenges in human evaluation. In our preliminary study, we observed that human evaluators often struggle to maintain focus when reading documents containing thousands of words, which could potentially compromise the accuracy of their evaluations. Moreover, while segmenting these lengthy texts into smaller, content-based portions may simplify the task, this method risks disrupting the narrative flow and connections between different sections, potentially resulting in a loss of overall coherence. We strategically segmented the documents for this study. However, developing more effective methods for human evaluation of ultra-long texts remains an area for future research. Target audience. Literary texts are crafted with specific target audiences in mind. In our study, we initially aimed to distribute our questionnaires through an online forum dedicated to web novels, intending to gather feedback directly from the target audience. However, this approach faced challenges either due to community regulations or the slow pace of feedback collection. Additionally, although we confirm the interest of human evaluators in Chinese web novels before they participate in the evaluation, there is a possibility that evaluators might claim interest simply to qualify for the job, regardless of their true preferences. Consequently, this could mean that our evaluation results might not accurately reflect the true preferences of the target audience. Evaluation scale. Due to constrained resources, the scope of our evaluation scale may be inadequate. We segment only the first 2 chapters of each book in the test set and gather a minimum of 5 valid responses per segment. Recent studies highlight the significant diversity in human preferences. Consequently, the limited scale of our evaluation could affect the outcomes. Human written references. Although the reference translations are said to be authored by professional human translators, there is a likelihood that these translators may use commercial machine translation systems such as Google Translate to reduce their workload. Unfortunately, we cannot verify whether the reference translations are genuinely created by humans. We acknowledge these limitations and leave them to the future studies. 10. Conclusion. In this paper, we introduce TransAgents, a novel multi-agent virtual company designed for literary translation that reflects the standards and translation publication process. Utilizing a multi-agent approach, this system effectively tackles the intricate nuances inherent in literary texts. We propose 2 innovative evaluation strategies: monolingual human preference, MHP, and bilingual LLM preference, BLP, to assess the quality of the translations. MHP evaluates how the translation resonates with the target audience, focusing on fluidity and cultural appropriateness, whereas BLP employs advanced language models to directly compare the translations with the original texts. Although the D-Blue scores are lower, our empirical results demonstrate that translations produced by TransAgents are favored by both human evaluators and language models over human written references. We also provide detailed analyses of the strengths and weaknesses of TransAgents, highlighting possible directions for future research. This concludes the reading of Perhaps Beyond Human Translation, Harnessing Multi-Agent Collaboration for Translating Ultra-Long Literary Texts on Research to You. If you would like more papers added, please leave a comment. If you would like to be notified when more papers are available, be sure to subscribe, like, and ring the bell.